welcome to the stream, I guess. So, we are building an engine, I guess, to test these. Focus. Come on. Come on. They are TF engineering 3D printed, lift arms with ball bearings. Not the model I would choose. I would choose the one with the pinholes on the side. But it is what it is. The main goal is to build an engine where we can test the difference between an engine with those and the engine without those. So these are going to be, in a position so that we can change them and install regular lift arms instead of them and see, compare what the differences are. So we have two unmodified switches here, since we're not gonna probably get to the stage where we are gonna use them, but these are not relevant. Let's see what kind of damage we can do. So we're gonna use a 5-stud. Since this is an experimental engine, this engine is not intended to be a product or even some performance engine or whatever. It's gonna be a compromise on so many fronts, but that's not the point. I mean, it was obvious that it would be a compromise from the beginning, because it's a test engine. We just want to see the difference between this and that, basically. We'll see. A few lift arms for the crank. I don't know. Since we are using 5-stud crank pieces, we could, as well use these for crank pieces because they are sturdier. Sturdier, they're gonna be better, I guess. So the crankshaft will probably look something like this. Just a second. So we would have these on each side, or each crank pin, then this and this. So this would be the crank, and we would have a 5-stud lift arm between them, or no, a 4-stud. Of course, a 4-stud lift arm, because we are going to do this here, like this. Then we're gonna have the ball bearing piece, which apparently is on very tight. Okay, very tight. Then we will have a flip-flop beam between them, or not. No. Ideally we would. Let's try it like this. Okay. And of course like this. Since we want the bearing to be as close to the crank as possible. Okay. Let's see. Okay, this goes very smooth. Very smooth. They're going to be obviously 90 degrees apart. Yeah, and this is it. So this would be one version. The other version would be exactly the same, with the difference that we are going to have regular lift arms. You see? So we would have these two versions. One is regular lift arms, the other is bearings. Which one, spinning them like this, there's not much difference. I mean, technically this goes a little bit smoother than this, actually. But this is irrelevant because there's no load on it. The relevant part is when there's load on it. Then that's where the ball bearings shine. That's what we want to test. Like this is, it's not much of a difference. Obviously, since we are using just the lift arm, we need to be a little bit creative with the way we're going to approach the whole bracing. So ideally, we will have I have just those. I would never use these. Never. Absolutely never. I don't know why anyone would use these. They are useless. But for testing purposes, we are using those. Sorry. They make everything just bigger. So let me get this correctly. Yeah, of course, it's too short. Exactly this one too short. But I wanted to have this one so I can do some bracing. Yada yada. Yeah. Apparently not. Apparently I need longer ones. Come on. There we go. And these holes are not deep enough for these to sit in. Maybe these are. These aren't either. Okay. So yeah, I don't have my drill. Let's see if I can do something with my hands. I mean, we're going to design it like this, and then I'm going to drill these a little bit more so that these grooves here can sit in more. Otherwise, this is gonna have a gap, and that's not gonna be good. So yeah, I'm gonna get the drill later off the stream. Okay, so we need, what are these? We need a 13 for our test engine. Of course we do. Yes. Come on. Oh, yeah, my luck. Obviously that would happen. There we go. There. They're just pressed in, so no big deal. Totally normal. Come on. There. Yeah. I understand. These are prototypes, obviously, but you know, for testing purposes, I need to deepen them so we have a fair comparison. You know, so we don't have this. You know, on this side, it's not an issue because we're using this part of the pin. You know, here I will just drill them a little bit, and it's gonna be fine. So no big deal. For today, it's irrelevant anyway because we are just designing them. What? No, there's absolutely no need, no reason to use these except for the fact that we have just those. The cross block is better in every single way. You know, there's no reason to use those, but you know, we are. So that's how it is, and you know, we have to go with it. So. Before we continue here with anything, we need to consider how we're gonna support all of this. So, why is my brain not functioning? So we are using this here. Come on. Okay. Now we have two choices where to put the cylinder. I would like to put it on this side, so it would be flush against this one here, and the other one, of course, the opposite. You know, it's irrelevant. We need to find, of course, a way to brace the cylinders. I'm thinking of. Well, I cannot use the similar system as in the small cylinder i4 because we have these here. Ideally, I would, you know, have this guy here, like this. Ideally, I would have this guy here, and I even might. Because this hole perfectly corresponds to the hole for this. Yeah, you know, I have these, so I might just use them. And this would be perfect way to brace all of this without any effort. And I'm all about as little effort as humanly possible, since this is a test engine and it needs to be easy to disassemble. So we're gonna use two identical supports on each side that can be just taken off in one piece, and it's gonna be fine. you know, simple as possible. Of course, we need to brace the bottom here, and you know, we have to make a stand so it doesn't fall, I guess. No problem. No problem. So we're gonna use this here and this here. This is enough. Sorry. There. This is the hole for the axle supporting the cylinders, and we're gonna use this here. Yeah. Okay. Fine. Fine. Okay. Good. On the other side, we are using this and this, and you know, I really hope that Leva brings out shorter flip-flop beams, just like Kata has. That would make life inherently easier. You did. Yeah, no. No. Absolutely not. You know why? There's a simple reason why I never use these. And the reason is, come on, that these connectors, these are non-friction pins, you know, and non-friction pins wobble. It wobbles. So I use these in this combination only if I can do this. Then it's fine. But here I cannot. So we're not doing this. But this is gonna be fine. I promise. It's gonna be fine. It's gonna be simple, fine, you know. And this is not gonna be a production engine, you know. This is not an engine that we're gonna make as a product or a model, whatever. Just testing. It needs to be simple. And of course sturdy, because if it's not sturdy, you know, we are not getting the results that we want. There we go. Simple to manufacture and simple to... Okay, now I want axles on both sides, but I don't want to glue them. I don't have to, because yeah, these are gonna hold them in. Okay. My problem here is I want this here, so we're gonna flip this. Yeah, we are gonna have to flip this. Four, yeah, okay, yeah, 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 yeah. Mistakes already. There, yeah. So we're making this. You know, you want to have the ball bearing on the crankshaft side. At least in our example here. This is a scientific experiment where we need to, you know, we need to give the concept the best chance we can. Whatever, I'm gonna use I don't know on which side I'm gonna have the valve train gearing or whatever. I'm just gonna use a 7-stud 7-stud axle on each side. So here we go. And there. Okay. So now we're gonna use these here. Now technically, there's a lot of controversy here. I could use this setup, or I could use this setup. So basically, we are going to use this setup. I don't want this here to catch on any of these flip-flop beams. In the inline 4 engine, it's fine because we have a 1x3 lift arm mounted like this, and it's perfectly smooth on this side, and this here cannot catch anywhere. Plus, we have the issue, of course, that we are routing tubing through here. But thinking of it, we will route tubing through here. Now, the only way this could catch is here, but that's... I'm gonna risk it. Yeah, whatever. I'm gonna do it like this. Save us on bricks. There. Okay. Now let me think. Can we get away, or would we want to get away, and by not having... Yes. Yes, we're gonna do it like this. Because we can, in this case. So in this case, we can do this as a first. So no axle, but pins. Like this. And at this point, our engine is perfectly symmetrical. It could be either this, like this, or this. It's gonna be like this, of course, because the valve train is gonna be on this side. We're gonna route the tubing through here because the valves are gonna be obviously, flipped like this. Ideally, or whatever we gonna do. I don't know. And these are gonna have their guides made out of these, of course, like this. Or yeah, we have to go one step further out, simply because the the connecting rod. Otherwise, we could have everything here flat, but we can't because of this, because we need to leave the gap here. Yeah, and these have to have a smooth surface to run on. I'm just thinking on how to make this as parts efficient as possible. Yeah, nothing. We're gonna do it like this. It's gonna be easy peasy. Easy peasy. There. Okay. Well, basically, this is superfluous, but it's fine. Okay. The length here is this, of course. And now we need these. There. There. One side done. On the other side. Yeah, this is an inline tube. A test engine. Ah. Okay. Go. It is already running. I'm gonna place this here on one side, so just so I can spin it. Yeah. So runs very nice. Now for the valve train, and here Ben has done some thinking, so we don't have to. Let me just look at the picture that he posted. Let me see. Where is that picture? Where did he post it? Ah. Okay. Just a second. So we got Oh, Krista, I have again fucked it up. Right. I'm sorry. Yeah. Okay, so we need to test this setup out of this here, or yeah. I mean, it's a very interesting idea. I have no idea if it works or how it works. Basically, we are gonna use these somehow. Right, they don't correspond. How are we supposed to use this? Since you cannot stack them like this, or rather you have to use them exactly like this. Shit. So the idea would be that we are running these, and then we have the axle of the lever in between. Yeah, but they don't go together, no matter what we do. Simply because, come on. What am I missing? Ah, okay. So we need to modify the parts. I see. Okay. If we are using the Lego way, we could use Kata parts, but no. Yeah. So basically, what we need to do is we need to cut this up a little bit. Let me get my knife. So I have enough, I think. So we're gonna have to modify this. Okay. Go. Both. Yeah. Both need to be modified, of course. Go. There we go. I hate, hate. I don't like the fake cylinders. So the engine with the fake cylinders, because they're just shit for the models that I do. They have no power. The crankshaft is garbage. I understand the motivation and ideas, because when I first encountered those fake motors back in the 90s, I had similar ideas, but ultimately, if you want usable power, they are useless. I think adding a bush to this isn't gonna solve our problem. Okay, so let's do a oh, here. I think so. Don't get me wrong. Don't get me wrong. They are a nice curiosity. I'll give it that. They're cute. We need 1.5. Okay, yeah. And I want to brace this as well as possible. Maybe in smaller scale models, but the problem is if you have to have the crankshaft braced at every pin still. If you don't, the crankshaft will just do this, and it's gonna be garbage. Yeah, I understand. I understand the motivation and the appeal. I'm not ignorant of that. Don't get me wrong. I don't know. We'll see. Maybe it'll work, maybe it won't. We're in the business of testing today. So, we're testing. We are testing. You have to modify parts no matter what you do. Whether it's the fake motor or not. So, you're screwed if you do, and screwed if you don't. Yeah, sure. I mean, I'm not saying they have no use, or that they shouldn't exist. Not at all. They absolutely can exist. What am I doing here? What the fuck am I doing here? This is just ignore whatever I wanted to do with this. I don't know. doesn't matter. Okay, so let's take a gear and let's see what happens here. What exactly does happen here? Basically, we do have a switching, but the problem is it enough? Because the lever, you know, has still a lot to go. Is it enough? The lever, of course, is stiff because it's an unmodified switch. So modified switch will be much smoother. It's jolting it, you know, at the last bit here. You know, here I am not a huge fan of this. Yeah, the angle is quite small. Yeah, I agree. The angle is quite small, but I like the idea. I like the idea. The small angle, yeah, it spends too much time. Technically, I could technically, but I won't. Because a shorter lever is gonna get us in trouble. First of all, what am I gonna do with the switch if I'm testing this? What am I gonna do with the switch with a shortened lever? That's garbage. I can throw it in the bin. Then, of course, the half a stud problem is not such a big problem. We glue bricks on this and we can deal with this easily. That's not a problem. But the half a stud lever, I don't want to do that. If we place the cams beside the lever, I don't think so. Or if the lever was here, for example, you know, if it was here, I'm just gonna hold it in my hand if I can. What would happen? No, that doesn't seem to be good. Or no, and it's absolutely not reliable. You know, if we would do this. Only an axle fits here, of course. We cannot have any pins or anything, just an axle fits here. Yeah, even that is not smooth at all. But this is such a good idea. I want to make it work. The problem is we're never gonna get enough deflection. Never gonna get enough deflection for this to work properly. Which is sad. But it is what it is. I don't know. I mean, for the test engine, we can go, you know, with the standard crankshaft, camshaft. Sorry. The camshaft that I use in the inline 3 engine as well, it requires some gluing, of course. I'm gonna look if I have some pre-glued gears. Maybe I have some pre-glued gears, so I don't have to glue. Let's see. I should, I think. But on the other hand, I don't seem to have a pre-glued gears. Oh, wait. No. Wait. Oh, these were glued at one point. These were glued at one point, which is good. Which is basically what we need. So we're gonna use this one. I'm gonna use this one. So why are we gonna use this one? Because we want the shafts to be parallel, and since this one was glued at one point, it has a, I don't know if you can see it, but it has a super glue created axle receptacle in it, which is good enough for us. We want exactly this, so I don't have to glue them. And the point, of course, is, the point of all this is that this happens. You know, since if we would use two of these, they would never mesh like this, but they would be one tooth offset, which is, you know, it works, but it's not optimal. But this is fine, so we can use this one. So great. No super glue necessary today. But we still need to use need to create the entire, you know, driveline the same as we had in the inline 4, because we are using two switches that are going to be yeah, obviously they need to be cut off so that they can be here. Yeah, they're gonna be here, so that at what point are we gonna insert them? Yeah, I want them to be here. Or no, let's go one step further out. Yeah, so that we can have the brick here glued to this here, and then the brick connects to this lift arm, and then it's fine. But they're gonna be here, like this, so that the tubing here goes through this gap. So we're gonna have them in this position, so there's enough room for the tubing to bend around all of this to reach this. Yeah, obviously I have not prepared switches for today. I'm sorry, but I just, you know, I had a headache today and I was tired. It's the story of the whole last few weeks, basically. The weather is shit, you know, it's raining the whole time, every day. I have a lot of work, and I just, I just didn't feel like it. It wasn't to be. But we can do the camshaft and everything still, we know where these go, so that's no problem. And we can do the gearing, basically. We're gonna use well, I don't know what we're gonna use, because the cam lobes are gonna be come on. We are going to use these as cam lobes, of course. So I'm keeping this here to test a little bit the camera settings. So since the background is a little bit darker, maybe the light metering from the camera is gonna be slightly better than usual, I guess. Right. So the cam lobes are gonna be in the middle. The cam lobes, the gears. So we're gonna have the gears here in the middle, between the switches. Yeah. We're gonna have, come on. Here and here are going to be these. These are I shouldn't talk with a full mouth. So these are going to be the switches. Then we're gonna have a support here and here for the gears, and of course the cam lobes. Let me think. No, I'm gonna have it like this. Hold on. This is then the plane of the. Okay. And space here. What I'm going to space this out with. Yeah, might as well. Might as well. Always remember, this is a test engine. If we would be doing things, for product or whatever, for an engine that actually has to fit somewhere, we would be doing it differently. But I want it to be easy to disassemble, easy to change the bearings, easy to do everything. So in this case, it's alright, I can get away with it. So here is where things get a little bit controversial. I'm going to use this row here. It's going to be a longer lift arm, just on this side. There. Just these for now. There. Okay. Now we have this and this. No. Sorry. These. Wait, do I have perhaps some switch bodies with this on? No. I don't. But these are so let's pretend that this is a switch. Just a second. An alarm just went off. Let's pretend this is the switch, and we're gonna make another one, of course, for the other side. These are our switches. Okay. Just a second. Yes, okay. The levers, so these here, are going to be here. Okay. So we need, what is this? This is a liner. Not liner. This. It's an 11 stud. Okay, 11. Yes. So we have this guy here, this guy here. So these are the gears in the center. They need to be braced, of course. That's not such a huge problem, and we need to have, you know, something here and something here. To do this most efficiently. Well, I know how, but ideally, I'm going to use those color packs. They are going to provide everything we need. Everything in one nice package. So, it's a test engine, and I can get away with it like this. Okay. And here we are going to do the following stunt. So, switch 1, switch 2. Then we're gonna have these here. And then we put on this here. Come on. There. See? Camshaft in place. Now we need to do the cam lobes. We are going to do on both sides. This here. There. And this here. And then we have the lobes. There. And there. And now, of course, we have our camshaft. We need to brace these and these here with a lift arm, and then we're gonna have a lift arm here. That's gonna connect this. Oh wait, I don't know what. Actually, I don't know what I'm gonna do this here yet. I don't know what I'm gonna do here yet. So this is the back of the engine. We are going to have this here. This here, yes. Okay. Now, the switch is gonna be, the lever is gonna be down below. I'm gonna use exactly the same thing that I'm using on the small cylinder inline 4, because this is basically, a version of it, just with 2 cylinders. I expect great RPMs from it. So we don't have to reinvent the wheel here. That's the main goal. We don't have to reinvent the wheel. Whatever. There. Okay. There. Now we have cams, so the gears. This here, and then we have these 3, and this here. But since this is a little bit different than the inline 4, we cannot use the same gear train because we have one stud more to cover. One stud more. So maybe if we use these here. Let's see. Okay. Look. No. They would need to be bigger. That is not really. Not really. Because, you know, we want them to spin in the same direction. So that's why those are in between. Could we make it with just these? No, I don't think so. Damn it. These are quite small. You know what? Since we have one stud room here, we are going to, you know, change this here. It's gonna be fine. Have this lower. But yeah, no. Then this changes. Yeah, I know. I know that. Still, it's not exactly like this, but it has to be symmetrical. It has to be symmetrical. No. No chain. No chain in my engines. Chain sucks. Trust me on that. As I said, no chain. No chain. We are not using chain. Countach is at the moment shelved. Everybody needs a little break from it. These are impossible to daisy chain, right? Yeah, because it's a half a stud there. Wherever I put this, it's not right. Sorry. It's always some half stud or Such a straightforward build, and then thwarted by one stud. Established, this is too short to be useful. Yeah, but that's not so simple. Much more difficult than you think, especially timing it. That's why that's why I like this. And here then you have odd number of gears. I like to drive the gear that is spinning the same direction for the camshaft. Yeah, I hate those moments. I hate this. Could be so simple. I mean, simplest would be if I would shorten this by one stud, but then I create a whole bunch of other problems that I don't have now. Just a second. If I make this lower. Yeah. Yeah, we have to go lower, and that's gonna be it. But before I do that, I need to go pee. you know, you cannot work with a full bladder. Okay, let's see how nicely modular our build is. Okay, yeah, we didn't have anything there. Okay. Okay, work on that. But so we're gonna lower this by 1 stud. Basically, we're making the con rods shorter. Since this is not a production engine, whatever, I'm just gonna do the odd party trick and, you know, do this. Of course, we need to lower this, but there we go. Now we need to lower these. I hope it's as easy as I imagined. Let's do it on one side only. So we need to lower this hole. For that, we need to turn this if we have it like this and we want to go lower, we basically just turn it around. Yeah, just turn this around. And we are game. Obviously there's gonna be some additions like this here, very important. But we are here. Okay, we are working again. Okay, we could make it, you know, smaller here, but I don't care. Doesn't matter. Okay, this is done. Okay. Only one here on each side. Have fewer parts still. There. And we're back in the game. Back in the game. Okay. The roughness is, of course, because you know these need a little bit of drilling, but this is pretty, you know, pretty smooth, pretty nice. Okay. So these are like here, here, and we need, of course, yeah, we still need these. And we are back where we want it to be. And now we are in the perfect spot. Perfection. There. Now we can use the exact same setup that we have on the inline 4, the small inline 4. Because these guys now fit. I mean, obviously they fit, but I need to, yeah. Why don't they fit? What is the problem? Okay. Yeah. Okay. We were generous with the spacing here. Okay, we don't need that much space. Okay, we can go slimmer. Okay. Wait, how did I do that? Yeah, okay. Okay. I'm complicating things where things need not be complicated. And now our dummy switches are of no use to us because this needs to be smooth without the knobs, the studs. Do I have modified parts? Doubt. Don't. Yet. Since we need to do this anyway. Now we do have them. So these are the switches, of course. These are the switches. There. What are we gonna do here? What are we gonna do here? I don't know. Something. Yeah, the next project is the E32 ring. It is already, it has been already decided. No, we can do this. Yeah, we'll see how nice it's gonna be, you know. Since, you know, we need to make it better than the models that came before it. That's always a, you know, an interesting challenge for a new model, being better than what came before it. Okay. So this is nice. And now our guys here fit. They fucking fit. Need to make them fit, you know, properly. Let's see how we're gonna do that. Yeah. There we go. I should take pointers for improving the inline 4 here. There are definitely things that I just learned to improve the inline 4. Yeah, a winner was selected. I don't know. I don't remember who it was. And he received the wheel hubs as promised. But I just don't remember. I'm too old for this shit. Okay. There we go. The clicking sound is, of course, this here. As I said, we need to fix this. No problem. And then it's just the tubing, and we're done. This is it, basically. This is the engine. This is the engine that's gonna, provide some insights. So I'm going to do the tubing as well. Not today, of course, but the tubing is gonna be done. We can do it tomorrow. We have to modify 2 switches as well. Do the tubing, and then it's basically doing the runs. Then it's basically making a run with these bearings, recording it on video, documenting how fast it goes, and then changing those blocks for, instead of using the bearings, no bearings, basically just normal lift arms, and comparing the differences. Will there be any differences or not? I don't know. Maybe. I hope so. I hope the ball bearing thing is gonna be faster. By how much? I don't know. I don't have a RPM meter, which is sad. But who told me last time that he has the was it the Renato or someone else? I need to ask. So we can properly measure the RPMs. The Lego speed computers are all garbage. They don't go fast enough, and all the cables I had for them the cables just disintegrated. So they are pretty much useless. It feels nice, yeah. It actually feels very very smooth. Okay, there's no switches, but as is. But still, we need to fix this because it stands out a little bit, and then it will relieve some more pressure, and it's gonna be even smoother. And of course, the main difference is gonna be under load, not when you're just rotating it like this. It's until there's load on it. Also, I'm not gonna use any balancing shafts because it's a short crank with using these. I don't think it needs a balancing shaft, to be honest. I don't really think it needs one. Yeah, so that's it for today. Tomorrow we are going to have a working engine with tubing, and then we'll see. We'll see what is happening here. I need to remember this part here. I think we can improve the inline 4 with this. Food for thought. Maybe. Yeah, maybe. Also, no, tomorrow we don't do the V8. I mean, I wanted to say that we have plans for a V8, of course, out of the small cylinder engine. That V8 could be sick, you know, but it's gonna, you know, the center part here, this part, it's gonna require some re-engineering, possibly. I don't know. We'll see. Yeah. Anyway, that's it for today, and I'll see you tomorrow at the same time, same place. And you know, thanks for watching, and keep on revving.